Last time I had done the Facebook interview in 10 minutes. Let me see if I could do the Amazon this time in less than 10 minutes. Hopefully I can, but I don't know. We'll see. Amazon is normally harder than Facebook questions, but we'll see. Is an Armstrong number if and only if the kth power of each digit sums to n. Oh, I see. Okay, well, let's see. Let's copy that number. And then while n is greater than 0, then what we want to do is what? I'm going to take the last digit, and with that I will just say last digit is equal to mod by 10, and then I'm going to modify, or yeah, Python doesn't have that, so I'm gonna make sure that the n divided by 10 is now, so if for this example I'm gonna take the last digit 3 and divide it by, or yeah, the last digit 3, that's the mod 10, and then I'm gonna divide it by 10 to make it 15, and so on and so forth. So total so far is this. So now what we're gonna do is we're gonna go total plus last digit squared, and in the end what we need to know is whether the total equals n. Okay, so I guess it doesn't want me to do that. The last digit is actually, oh, that's not even right in the first place. It should be last digit n. So I must be off by 1 here, because 153 should be true. So let me see, let me print n here, see what happens. So n is 53 and then 1. So let me print last digit. One. Interesting. So last digit. So what's the total when all is said and done? 5 squared. Wait, that's not right. Oh, cubed. Cubed, not squared. Okay, so let's see. 2. So 2 squared should be false. 2 cubed. The kth digit number n is an Armstrong number if and only if its kth power of each digit sums to n. Why is 2 supposed to be true? 2 cubed is 8, and that should be false. Why is it expected to be true? The kth digit number n is an Armstrong number if and only if the kth power of each digit because the power should be the same as the number of digits there are. I see. So I need another one here. m num digits. Actually, I can count the num digits like this. That's so annoying. Why does it do that? Num digits equals count n here num digits. Not count. I don't know why I put count. It should be length. Okay. Let's try this. Alright, next question. I don't know if we're going to finish this because we only have 4 minutes now. Let's see. Return the root node of the binary search tree that matches the given pre-order traversal. So this is the pre-order. Wait, recall that the binary search. Return the root node. So this is pre-order. This isn't pre-order, this is... It's guaranteed that for a given TC, there is always possible. Return the root node of a binary search tree that matches the given pre-order traversal. I guess you're supposed to do it in level order. But that seems Oh, you're given the list. Okay, I got it. So what we want to do here is root equals so I can go to each item, right? So Q equals first item, if not pre-order, return none. Okay, so the first item is this, while Q, the next item is Q dot pop left. Probably want to do DQ here, and then I know that its children is 2n plus 1 and 2n plus 2 of the index. So so I'm going to make a node out of tree node out of the pre-order at that index. And if 2 times an index plus 1 is less than the length of pre-order, then I will go ahead and make a left node tree node pre-order 2 times n index plus 1. And then node dot left equals actually that's not what I want. I actually want the actual tree node already here. Pre-order 0. I actually already want the node here. Node dot left equals left, and then I want to say q dot append left. If n index plus 2 is less than length of pre-order, then I want to say right equals tree node pre-order 2 times n, not n index, I is initially 0. Probably better if I do instead keep track of the index. And then append the index with it. So left appended with its index 2 times I plus 1, and then q dot append right 2 times I plus 1 plus 2, and then that's pretty much it. I just need to return the root node, so I need to do instead root equals tree node pre-order 0, which I need to replace this with the root node, and then I will go ahead and return root. Let's see. 8.5 null. That's not what I want, but let's see. So the next item in the queue should be the left, and then the right, and they should actually, I also need to know that if they don't have 1, then node.left has to be none. Same here, else node.right equals none. That should be also a case. And then what's happening here? So print node.val. So I did 5, and then I did 8, and then 5. Oh, interesting. What I actually want instead is I need 8, and then I need 5. Yeah, but that's not exactly what I want. I need 8 and then 5. But I need oh, okay. So this is pre-order. So it's not necessarily the binary search. Oh, I see. So pre-order is always the root node, and then divide the thing in half. So that's not exactly what I want. I want to take out the root node, make a node, and then recurse and do the same thing to the sub array on the left and sub array on the right. Yeah, it actually, you're gonna have to break it towards the next maximum, or yeah, the next. This is not an easy question, so let's try this again. Let's define a make BST as something that takes on a list, a pre-ordered list, which is the same thing as that, and it takes in the index of the start and the index of the end. And when that's done, I want this to return a root node. Okay, so what we can do here is that if I is equal to, if I is greater than j, then we return none. If I is equal to j, then we simply make a tree node out of the first item, pre-order I. Okay, if that's not the case, then we make a root out of the first item, and then what we need to do is we want to recurse, and well, we first need to find the next smallest item to the first item. So in this case, or the next biggest, I guess. Right, so search item is equal to pre-order I, and then we're gonna find while so I equals 0. Oh, not I. X equals 0. While not 0, I plus 1. While x is less than length of pre-order, I want to see if I can find the next bigger thing than the search item. So if pre-order X is bigger than search item, I'm done. So return X, right? So if I didn't find one, then that means that everything is on the left child. So which is fine because that will just be none. So then I can recurse and say root dot left is equal to self dot make bst of I all the way to x minus 1, right? Because x is the next bigger item. So root that right is equal to self dot make bst x all the way up to the end j, and then we return root. Okay, so at this point we're supposed to return self dot make bst pre-order 0 all the way up to the length of pre-order. Should I do inclusive? So if it is inclusive, right, that's gonna be the case, and then this is going to be the case. Yeah, I think it has to be inclusive. Ooh, I need to increment x. What happened? 4 is not a valid value for the expected return type tree node. 4 is not a valid value. Where's 4 coming from? Let's see if this is even executing. So the first one executed. The problem is am I here? Not even there. Am I even here? Okay, so that's fine. 1, 2, 3, 4. 1, 2, 3. There's a search item here. Search item is 8. So that's interesting. It shouldn't even go to 4 because I'm not returning x. I am breaking. That's what it is. Okay. Missing one argument. Oops. Pre-order. Can't forget the array. time limit exceeded. Print pre-order I. So I'm staying in. I should remove the first item. First item is no longer in question. Oh my gosh, that took a long time. 25 minutes. So I guess well, we did have an hour and 30 minutes to do it. And I don't know why I thought I could do it in less than 10 minutes. I shouldn't have underestimated Amazon because their questions are always super difficult. But yeah, so that's what it is. Apparently they're easy and medium, but yeah. I'll post the report on this if I can see it. But yeah, that would be me trying to go through the interview if I was doing the interview. That made me sad.